Welcome to qnawire.
For part A, let's solve for the empirical formula of the helicane, starting from 0.5063 grams of the carbon dioxide. Let's find the grams of carbon. And this would be 44.0 grams CO2 per 1 mole. In 1 mole of CO2, we have 1 mole of carbon. And 1 mole of carbon, molar mass of 12.0 grams. This will yield 0.1382 grams of carbon. Now we can find the percent of carbon, which will be equal to 0.1382 grams of carbon over the total mass, the 0.1450 grams of the compounds. We can find the times 100%, and we can find the percent carbon is equal to 95.31% carbon. The percent of hydrogen, because we know this is a hydrocarbon, would be 100% minus 95.31%, and this will work out to 4.69% hydrogen. So here's our percent composition. From this, let's assume 100 grams of the compounds, and by doing so, 95.31 grams of carbon and 4.69 grams of hydrogen. Let's convert these to moles, and this will yield 7.936 moles carbon and 4.69 moles hydrogen. Divided by 4.69 would give me 1, and this would be about 1.7 times 10 would give me 17 and 10. So my empirical formula here is equal to C17H10. We can calculate the empirical mass. We don't need it yet, but we'll need this in part B coming up. And we'll find that the empirical mass here is 214 grams per mole. For part B, we're asked to find the molecular formula of the helicane. So let's solve for the moles of the helicane, which should be equal to the 0.0125 kilograms, and we're given the molality, 0.0175 moles of the helicane per kilogram of the solvent, and this will work out to 2.19 times 10 to the negative 4 moles of the helicane. Now the molar mass of the helicane would be equal to the mass is 0.0938 grams over the moles, 2.19 times 10 to the negative 4 moles, and the molar mass of the helicane works out to 428 grams per mole. We calculated the empirical mass up above in part A, so 428 grams per mole divided by 214 grams per mole works out to a whole number ratio of 2. Therefore, the molecular formula is equal to 2 times the C17H10, which works out to a molecular formula of C34H20. And the balanced equation here for this combustion reaction would be C34H20 plus 39 O2 gas will produce 34 moles of CO2 gas and 10 H2O liquid. So there's our balanced equation for this combustion reaction.